This is lesson 5, graphing inequalities. So we've been looking at solving systems of equations, and what we're going to be moving into is now solving systems of inequalities. But first, we're going to kind of pause for a bit so that we can learn how to actually graph inequalities on a graph. Okay, so we have some steps for us here. Our first step is to solve for y. So what I mean by that is some problems may be in standard form or some other form. We want it to be solved for y, where y is on one side all by itself. Okay, our next step is we're going to actually try and graph the line here. And just like you would graph a normal line, you would plot the y-intercept. So we'd plot the y-intercept and then use the slope for direction. That's where we do rise over run. Once we've found the y-intercept and we know which direction we're moving, we then have to choose what type of line. That's something that's different here with graphing inequalities, is sometimes we're going to have a solid line and sometimes we're going to have a dotted line. So we have to choose between the solid and dotted line. If you look to the right here, I have a table here that shows us when we're going to use a solid line, when we're going to use a dotted line. So notice that if you go through to the right here, a solid line always has that line underneath the inequality sign. So that's meaning it's less than or equal to, greater than or equal to. That means points are included on the line and those are solutions. Okay? Now, the dotted line does not have that line. That means it's just less than or just greater than. So we look at the inequality sign to decide if we have a solid or a dotted line. Then our last step here is we're going to shade. So if you like coloring, that's what we're doing today. So we're going to shade either under the line we just plotted, or we're going to shade over it. Okay, so to know if we are shading over or under, let me move this. So to know if we're shading over or under, we look again at that inequality sign. So for under, that means you have a less than. For over, that means you have a greater than. So this table here is for you to use to decide if we have solid or dotted lines and if we're shading under or over. Okay, so the solution to an inequality is in the shaded area. So as we look for solutions to these inequalities, we're going to be looking at what points, what coordinates are in these shaded areas. Okay, so let's get started with our first example here. So our first example, we have this inequality, y is less than 1/3 x plus 2. Okay, so first we need to know what is my slope. This inequality is still in that slope-intercept form. So we have our y mx plus b. Okay, so when we look at this, we want to know what m is. And m is 1/3, 1/3. Our b, which I'll write over here, is going to be 2. Okay, so we use this information in order to put this inequality on our graph. So I'm going to start with the y-intercept. The y-intercept is the b, the beginning point. So I'm going to plot a point where y is 2 on the y-axis. So that would be right here. Now my slope is going to tell us the direction we move. So this is rise over run, since it's positive, the rise is telling us we're going to go up 1. The run is telling us we're going to the right 3. So we go up 1 to the right 3 and plot a point. And I'm just going to keep doing this. Up 1 to the right 3 and plot a point. Up 1 to the right 3 and plot a point. So now that we have some good points here, it's time for us to draw the line. But remember, we have to look at if we want a solid or a dotted line. So we look at our inequality. We have a less than sign. So since we have a less than sign, that means we are going to have a dotted line. So if you look at that table in the top right hand corner, the less than sign tells us we have a dotted line. So I'm going to draw a line through here, but it's going to be kind of dashed like this. I'm going to extend the line all the way through the graph. It's important that you put it all the way through the graph. So that's what our line is looking like. And now our last step here is we want to shade. And so we have to decide if we're shading under or over. So if you look at that table we had at the top right hand corner, and we have a less than sign, and that's under the under column, okay? So we have a dotted line and we're shading under. So how we shade under, you can just take your pencil and just kind of shade underneath of this red line. All right, so now let's talk about solutions. We wrote earlier that the solution to an inequality is in the shaded area. So we're going to write some examples of solutions. So if we have solutions that are in the shaded area, that means something like this point here. It's in the shaded area. That coordinate is 2, -3. That would be a solution. Another one would be, let's go right here. This point's in the shaded area as well. And that coordinate is -6, -5. So these are just two examples of solutions. Now we're going to look at some non-solutions. So that means some points that are not in the shaded area, okay? So one point would be right here. This point is not a solution because it is not in the shaded area, and that coordinate is 3, 8. And then I also want to point something out that's very important. So let's look at the coordinate 3, 3, right here. Now, this point is on the line, but since this is a dotted line, it is not a solution. It has to be a solid line for a coordinate or a point on the line to be a solution. So the coordinate 3, 3 is not a solution. All right, let's look at our second example. Okay, we have y is greater than or equal to 4/5 x minus 3. So, first thing we want to do, it's already solved for y. We don't have to do anything with that. So we move on to finding the y-intercept and the slope. So our slope here, again, this is in that slope-intercept form. Our slope is going to be 4/5. Our b value is -3. So let's start with that beginning point, the y-intercept, at -3. I'm going to put that point here. And now we look at our slope, rise over run, to see the direction we're moving. So if we have 4/5, it's positive. That means our rise is telling us to go up 4, and the run is telling us to go to the right 5. So I'll go up 2, 3, 4, to the right 2, 3, 4, 5, and plot a point. And then up 2, 3, 4, to the right 2, 3, 4, 5, and plot a point. Okay, before you draw your line, we have to check our inequality. So this time we have a greater than or equal to sign. If you look at that table, at the top right-hand corner, find the greater than or equal to sign, and notice that's in the same row where it says solid. So since it has that equal to part, that means we are going to have a solid line. Okay, so now that we've drawn the line, we want to shade over or under. So look at that table again at the top right-hand corner. Find your greater than or equal to sign, and then see that that sign is underneath the over column. So that means we want to shade over this line, which would look like this. So we're just shading over the line. All right, so that's how we graph this inequality. Now let's look at some solutions and non-solutions. So examples of solutions. Remember, that means they're in the shaded area. So let's do this point right here. This coordinate is in the shaded area, which is -5, 2. So this point is a solution. Okay, now let's look at this point right here. This point is on the line. Now last time we said a point on the line is not a solution, but this time we have a solid line. So when we have a solid line, we have y is greater than or equal to, which means anything on the line is a solution when you have a solid line. So the point 5, 1, which is on that line, that is a solution this time. Okay, so some non-solutions. This will be anywhere in the unshaded area. So we could go right here. This point right here is not in that shaded area. The coordinate there is -4, -8. Another coordinate that's not in the shaded area, right here, 5, -3. We have one more example to go over. So let's look at this one. All right, we have 2x minus 3y is less than -3. So notice that this problem is not in slope-intercept form. We don't have y isolated or y by itself. So that means we have to solve for y here. So I'm going to draw a line down my inequality sign, and I want to manipulate this equation so y is by itself. So that means I got to get everything away from y. So the first thing I'm going to do is move the x term. So since it's positive, I'm going to subtract 2x from both sides. And we get -3y. Bring down the less than sign. And then -3 and -2x are not like terms. So we're just going to write them next to each other. -2x minus 3. Now we're going to divide by the coefficient of y, which is -3. So divide by -3 on both sides. And before we go any further, there's something really important we have to remember. Okay, so way back when, at the beginning of the semester, we solved inequalities like this when there was just one variable. And we learned that if you ever multiply or divide an inequality by a negative, something changes. And so what's going to change is this inequality sign. So in my class, I like to draw a little bell just to remind us, ding, 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 this, we have to change something, okay? So since we are dividing by a -3, we have to flip the sign. So the sign becomes, instead of less than, it's going to become greater than. Okay? So anytime you divide by a negative with an inequality, you flip the sign. All right, so now we actually can divide by -3. So on the left side here, we get y is greater than, and then we're going to bring back that heart method. Remember that, where we circle what we're simplifying in this fraction. So -2x divided by -3, that simplifies to just positive 2 over 3, because a negative divided by a negative is a positive. So we get 2 over 3x. And now we look at -3 over -3. -3 divided by -3 is just positive 1. All right, so now we do have an inequality in that slope-intercept form. Okay? So let's write out, now that we have this, we're going to actually put it on the graph. So m is equal to this 2/3. B is equal to 1. So let's plot the y-intercept first, the beginning point. So since b is 1, I'm going to put on the y-axis where y is 1. And then my slope, it's positive. It's telling me to go up 2 to the right 3. So I'm going to go up 2 to the right 3 and plot a point. Up 2 to the right 3, plot a point. Up 2 to the right 3, plot a point. Now we need to look at our inequality sign. So that inequality sign is now a greater than sign. So if you look at the upper right-hand corner of your paper again, let's just go ahead and write what type of line and where we're shading, okay? So because we have a greater than sign, that means we're going to have a dotted line and we're going to be shading over. So it's dotted and over. So as I go through these points, I'm going to make a dotted line. Just like that. And then because it's greater than as well, I'm going to shade above the line. Okay? So now we can talk about solutions and non-solutions. So some solutions, again, are where we find points in the shaded area. So we could use this point right here, which is -4, 3, because it's in the shaded area. And then we can use this point right here, which is also in the shaded area, and that coordinate is 2, 9. Now let's look at some non-solutions. This point right here would be a non-solution because it's not in the shaded area. That coordinate is 6, 0. And then let's use this point right here. It's on the line, but since this line is dotted, it is not a solution. And that coordinate is 9, 7. So this is how you graph inequalities and find their solutions.